Okay, with this lesson, we're looking at generating patterns using given rules. So this is something we reviewed we started at the very beginning of the year, but we didn't spend a lot of time on. So let's go back to refresh our memories. So first thing, we're going to compare two different rules we have and talk about one rule and what that means to have a rule in math. So this rule, the first one is start at 0 and add 1. So here we are, starting at 0, adding 1. 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, etc. This pattern keeps going and going, but they're stopping here because that's all we need to just illustrate this point. The second rule is start at 0 and add 3. So we're starting at 0, 0 plus 3 is 3, 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12. So each time it's adding 3 more because that's the rule. So what do you notice about these two rules? How many times larger are the numbers in rule 2 versus the numbers in rule 1? So when you're looking at this, you're going to want to compare. Well, 0 and 0, that's going to be the same. This one's 1 and this one's 3. How many times larger is 3 than 1? How many times larger is 6 than 2? How many times larger is 9 than 3 and then 12 and 4? And you're going to be thinking about, how do I get from 4 to 12 and 3 to 9 and 2 to 6? What's the same thing, the common piece? And it is that they are 3 times larger. Okay, let's do another one. Okay, so the rules are still the same. And this time we're comparing using ordered pairs. So which of the following are ordered pairs? 1, 2, 3, 4, parentheses, 0, 3, 6, 9, 12, 0, 1, 2, 3, 4, 5, 6, 9, 12, or 0, 0, 1, 3, an ordered pair. The key here is in the phrase pair. How many is a pair? And a pair always means 2. So ordered pairs are 2 coordinates, 0, 0, 1, 3. So the correct answer is choice C. So what you can do with that information is create a table. So rule 1 has the numbers all going down. Rule 2 has the same numbers all going down. So the first ordered pair in the table is 0, 0. What is the second ordered pair? Is it 4, 10, 1, 3, 2, 2, 0, 4, or 1, 2? Well, it would be 1, 3, because we're looking for the pair. 1 from rule 1, 1 from rule 2. So 1, 3 is the correct answer. Now what you can do with that is graph those numbers using a coordinate plane. So here's my table again with rule 1's numbers and rule 2's numbers, and I'm going to plot them on a coordinate plane. Okay, so for these two rules, the second number is always 3 times greater. The relationship between the two numbers is the same. Sorry, if the relationship between the two numbers is the same, the graph will be not graphable. Will it be a straight line, or will it be an exponential curve? That means, wow, we have all kinds of words. A circle or a parabolic curve. Exponential means exponential, it's growing. So a curve is a curved line. It's going to be growing and growing and growing in a curved line. Parabolic is a word you will never, well, you'll use it in high school. Parabolic means that it's going to start to come up and then it's going to start to go back down again. So it's making like an N shape. An exponential curve, I said, can go like this, but it can also go the other way like this, but it's always going to be going up and up and up. Okay, so if the relationship between the two numbers in the ordered pair is the same, the graph will be a straight line. So if it was 0, 0, and the next one is 1, 1, and the next was 2, 2, and 3, 3, then it's going to be a straight line, just like this graph is showing here. It's straight, it's not curving at all. Okay, let's look at this table with these two rules. So we have 0, 1, 2, 3, 4, 5, 3, 4, 5, 6, 7, 8. So here's the sequence of numbers. We're not worrying about figuring out what the rule is, but I do want you to look at the numbers, Find the ordered pairs and see which graph is the correct graph for these numbers. Okay. You can probably rule out some of them pretty easily. Let's look back up at the numbers. And then which graph shows these numbers correctly. And the correct answer is this one. Those numbers are steady. They're going up and up and up by 1. And if you look at any of these, all of a sudden this one goes to negative 20. That's a negative number. That one's not going to be it. This one has a 0, 0, a 5. And look at my numbers. 200, 400, 600. That was nowhere near the graph that we had. Same thing with this one. 50, 100, 200, 150, and 200. That's also not close to what we have. So really the only reasonable one is this second graph.